Hey guys, I'm Pat Kelly. Okay, in this problem, you see that they've given us the first few, looks like 5 terms to a sequence, and the directions are to write the apparent nth term, right? And they also specify, I got to make sure I remember that the first term is supposed to start with n equals 1. That'll be important. So this type of problem, what we're looking for as an answer is that a sub n, that's my a, that usually, in the earlier problems, they gave us this as kind of like a formula, like a recipe, right? And we would put in our different values of n and get these results. But this type of problem, you're trying to think backwards. They've given you the results, and you've got to come up with the formula. You need to figure out what this recipe is going to be, okay? These are very much try to find the pattern type problems, okay? So let me talk you through my thought process on this one. Each one's a little bit different, but you still want to try to find the pattern. And I'll see if I can give you a few clues to do so on your own. Like one of the clues is if your expressions have multiple parts, for instance, these are fractions, so you have both numerators and denominators, it won't necessarily be the same pattern that gives you the different parts. I say that in this case because what I'm going to do is look for a pattern that gives me each of these numerators. And I'm going to get that down. And then I'm going to kind of wipe the slate clean and look for a different pattern that gives me those denominators. Okay? So don't feel like one pattern is going to give you everything all in one fell swoop. Take it slowly. All right. Let's take it slowly and look at the numerators. 1, 3, 9, 27, 81. You're looking for a pattern. That pattern to me looks like powers of 3, right? So I think 3 raised to the n looks good. But here's where I need to remember that they wanted my first term to be n equals 1. So if I put a 1 in, if I were trying to check the first term of the given sequence, and I put a 1 in, 3 to the 1 power is 3, and that's not what my numerator is, okay? I'm just working on the numerator. Let me make that more clear. But again, if I put a 1 in, I'm not getting the numerator of that first term they give me. 3 raised to the 1 power, that's actually here, all right? So here's a trick. Another one of the tricks is I'm going to take this exponent, and instead of n, I'm going to do n minus 1. Now, again, check, and that's another clue, is check yourself a lot. I'll check again if I'm trying to get that first term, n equals 1, plug a 1 in for n, 1 minus 1 is 0, 3 to the 0 power, that does give me that 1 that's in the numerator. Cool. Let's check a few more though. If my n were 2, moving on to the second term, n of 2, I put a 2 in here, 2 take away 1 is 1, 3 to the 1 power does give me the 3 that's up there. That's good. All right. I like my numerator, and I could check it for each of the terms. You do want to do a lot of checking. Let's move down and try to find a pattern in the denominators. It's a little bit tougher maybe to see this one. 1, 1, 2, 6, 24. If it doesn't jump out at you, and a lot of these won't, start playing around a little bit in terms of what happens from one term of the sequence to the next. So for instance, to go from there to there, just in the denominator, I multiplied by 1. All right, well, is that same multiplication by 1 happening to go from the second to the third term in the denominator? No, I'm multiplying by 2. If I go to the next pair of terms, I'd actually be multiplying by 3. And here, I'd be multiplying by 4. So this is not a constant factor that I can do something comparable to what I did in the numerator. Instead, the trick here is to be thinking, to get from one term to the next, you multiply by the next consecutive integer. Notice 1 and then 2 and then 3 and then 4. And multiplying by the next consecutive integer is a factorial. That's tough to see. I want n factorial. But I'll pause for dramatic effect here. I'll put my exclamation point way over here. Because if I check myself, I'm going to find a little mistake again. If I put n equals 1 to check this denominator, 1 factorial, that is 1. I might feel good about that. But you move to the second term. Here n is 2. If I put a 2 in for n, 2 factorial is actually 2, and I missed. In fact, the 2 that I want is in the next term. So I have to do that same trick of n minus 1 actually before you do the factorial for this one. Okay? And again, I can't say this enough. Check yourself. If you check this denominator for n equals 1, n equals 2, n equals 3, and n equals 4, n equals 5, it works for each of these. So I feel very good about my answer, but only because I checked it a lot. Okay? Try these. These can challenge you a little bit, but you're looking for patterns. Write the pattern down that you think works, but check it, and then check it, and then check it again. All right? Go try some on your own.